We're in the middle of proving if you have a function that's integrable on AC and CB, then it's going to be integrable on AB, and also the integral from A to B is going to equal the integral from A to C plus the integral from C to B. And my strategy is I'm going to prove that the sum of the integrals, A to C and C to B, minus the integral from A to B, is going to be less than epsilon for all epsilon. So that boils down to proving that the integral from A to B minus epsilon is less than the sum of the two integrals, A to C, C to B, which I already proved down here. And then I just need to prove that the integral from A to C plus the integral from C to B is less than the integral of A to B plus epsilon. So I'm going to do that part now, and I'm going to look at the integral. Oops, let's change colors. The integral from A to C of f plus the integral from C to B of f. Well, what do I know about them? I know that they're bounded above by these same partitions up here. I have a P1 that makes this true, and a P2 that makes that true. So that's going to be bounded above by UF of P1 plus UF of P2. So I'm just using the definition of the U things. U things are upper bounds. So if you ever have a partition, this is an upper bound by definition of U. But I also know that UF of P1, this is going to be less than, if I added the L to the other side, I get UF of P1 is less than L plus epsilon over 2. That's less than LF P1 plus epsilon over 2. And very similarly, this thing is going to be less than LF P2 plus epsilon over 2, which equals LF P1 plus LF P2 plus epsilon. But we talked about this before. We've used this several times. Notice that I know that LF P1 plus LF P2 is equal to LF of P1 union P2, which equals LF of P. So we've used that fact as a clicker question, and it's come in useful already a whole bunch of times. Plus epsilon. Well, this is a lower bound. This is less than or equal to. It's a lower bound for the integral from A to B of f plus epsilon. So what I've done is I've proved that this thing, that this sum of integrals is less than, so I'll just replace this right here, integral from A to C of f plus integral of C to B of f is less than integral from A to B of f plus epsilon, which is exactly the second half of the inequality I needed. So what have I proved? I proved that the sum of the integrals A to C and C to B is always within epsilon of the integral from A to B. It's always less than when you add epsilon to it and bigger than when you subtract epsilon, which boils down to the sum A to C, C to B minus the integral of A to B is less than epsilon, and epsilon could have been any positive number. So the only way for two things, and these really are just constants, right? That's just an area, that's an area, that's an area. The only way for these two numbers to be less than every positive number is if when you subtract them you get 0, which is saying that they're the same thing, which proves the result. And we're done.